Okay, hello everyone. So we'll have here the DICT ICT Proficiency Examination Reviewer. So for now, we'll be discussing object-oriented programming. So on this part, we'll just be discussing some concepts of OOP. Since we know that OOP is a very lengthy topic, so we'll just be covering some of its concepts just for the review of our uh, proficiency examination. So the topics covered here, of course, is what is OOP, and then uh, classes, and then objects, of course. Then we have the principles of object-oriented programming, which are encapsulation, inheritance, polymorphism, and abstraction. So let's start with what is object-oriented programming, or simply OOP. So object-oriented programming, or as we know, OOP, is a programming paradigm that revolves around the concept of objects. So as the name itself implies, it is object-oriented, so which are instances of classes. So for us to clearly understand what objects are, so we need to focus first on the classes because as have been mentioned, objects are instances of classes. So without our classes, we basically cannot create the objects. So let's talk about classes. So what are classes? In object-oriented programming, a class is a blueprint or template for creating objects. So within a class, we can define different properties or attributes and behaviors or methods that an object of that class will have. So here we have an example, of course. We have here the car class. So as you can see on our car class, we have here some properties and some methods. Okay, by the way, be noted that Java is the programming language used in this example. By the way, Java is one of the languages that you can choose upon applying for the DICT ICT Proficiency Examination together with C, C++, C#, and VB.NET. So within our class, we have included some attributes. So in this example, these attributes are called instance attributes. By the way, we have two types of attributes. We have the instance attributes, which we have here in the example, and then we also have class attributes. So instance attributes are specific, okay, to each individual instance or each of our objects of our class. Meaning if we have, let's say for example, we have two instances of the car class, the value of make, model, and year will be different per instance. So that is the essence and purpose of instance attributes. How about class attributes? Class attributes, it doesn't matter how many instances of the car class we have, it will be the same, okay? The value on the first instance and the value on the second instance will be the same for each of our objects. Talking about class attributes. Then we have our constructor. So what is a constructor? It is a special type of method that is used to initialize objects of a class. So typically, any initialization that we want it to happen during the instance of our class shall be written inside our constructor. So as you can see here, our constructor has three parameters, and each parameter is given to be the values of our instance attributes. Meaning, once we created an instance of a class or we created an object, so we need to provide three arguments to suffice the three parameters, and that will be thrown and be given to our instance attributes. So constructors are automatically called when we create an object of our class using the new keyword. So later during the discussion of objects, we'll have that one, of course. So like methods, like any other methods, again, a constructor is still a method. It's a special type of a method. So we can actually overload constructors. So when we say overloading, we'll have this as well on the polymorphism. So just a brief idea. So meaning we can have multiple constructors within a single class. Just so happen that we need to differ the number of parameters. So let's say, for example, our constructor here has 3 parameters. That means I could create another constructor with 2 parameters, another constructor with a parameter, or a constructor without any parameters. So it's up to me how will I set things up on each of my constructor depending on how I want the implementation would be. But that is one way on how we can overload our constructors. So with that, our program, once we create the instance of our class, will determine based on the number of constructors being, based on the number of arguments being passed once we are creating our object. So parameters on this example, so these are variables that are used to pass values into a function or method when it is called. So they define the data that a function or method requires to perform its task. So in our example, we have here 3 parameters. 2 of them are string and 1 is an integer. That fits our attributes, which are 2 strings as well, and then 1 integer. Next on our classes, so as we have mentioned, classes is a collection of proper attributes and methods. So we have here some examples of methods. The first one we have is the get make, and then the other one is display info. So get make is an example of what we call an accessor or a getter. So what are getters? Getters are methods used to retrieve the values of private instance variables. The main idea or the main concept of creating a getter and a setter, its counterpart, is when we have private attributes. So based on our example, we have 3 private attributes. We have the make, the model, and the year. So basically, we should create our getters and setters for each. There should be a get make, a set make, a get model, a set model, a get year, and a set year. Okay, so that's how we really manipulate and maximize the use of these methods, getters and setters, when we are or when we have these private attributes. Okay. And then we can create other methods, like on this example, we have the display info. So on display info, we can do anything we want. We can do our own implementation, but when we say getter, it's meant to return a value. When we say setter, it's meant to set a value. So they have a fixed purpose, not like our created or other methods within our class. Now let's talk about object. So since this is object-oriented programming, so this is typically the focus of our discussion. So an object is an instance of a class. So it represents a real-world entity and encapsulates both data, which are our attributes, and behaviors, which are our methods. So earlier we created the car class, right? So I hope that you can still recall. So for us to create an instance or to create an object, we are using the keyword new. So based on the example, we have here 2 objects, which is car1 and car2. Then to create an instance or to create it or to complete the object creation, we use the keyword new and then we call our class. So our class here is car. Then remember, based on the structure of our class, based on its blueprint or on its template, we need to pass 2 string arguments, right? And 1 integer argument. So here on the car 1, we pass Toyota Corolla in 2022, and then car 2 is Honda Civic in 2021. So we need to follow the structure of our parameter list on our argument list. Now upon creating the objects, now we can call the methods or anything available within our class. So typically what we can call are those set in public. Okay. Those private attributes, we basically cannot call it because they are not known by our method, or sorry, by our object, because the private means it's only accessible within the class itself. So to invoke methods, Java is using the dot notation. I think most of the languages um, allowed by DICT on its examination is using the dot notation to call its methods and properties. Now let's talk about the principles of OOP. Let's start with encapsulation. Encapsulation, by the way, is one of the main ideas of OOP. We need to encapsulate, or we need to bundle attributes and methods that are operating or focusing on the same task or same unit. So the idea of encapsulation is to hide the internal state of our object from the outside world and allows us to only expose necessary functionalities. Okay, this one way is to manipulate our access modifiers. So like earlier, we have set some attributes to private and then some methods to public, meaning we are limiting the access to those attributes because we set them to private, and then the rest can be accessible by the world through public access modifier. So let's have that example again, our car class. So here we set our properties to private, as we've mentioned, because we don't want them to be easily accessed by our or typically by anyone. Okay, we want it to be properly managed within our class. That's one of the reasons why we are creating getters and setters. So access modifiers, so these are keywords, okay, that control the visibility or accessibility of our classes, attributes, methods, and even our constructor within our program. In Java, by the way, be specific in Java, because in other languages, there are other access modifiers. Like in VB, we have the friendly or friend. I could no longer recall, but we have that weird additional access modifier. So in Java, we have 4 modifiers. We have the public, we have the protected, then the default, meaning there are no modifiers visible, and the private. Now let's talk about inheritance. So inheritance is a mechanism where a subclass inherits properties and behaviors from our superclass. So the main idea or concept of inheritance is to promote code reusability, meaning any existing from the superclass will be reused by the subclasses. So let's have here our example. So in this example, we created 2 classes. The first one is our superclass, which is the vehicle class. And then we have our subclass, which is the car class. So the idea of this example is for the car class to inherit anything from our vehicle class. So when it comes to inheritance, our subclass can inherit those properties and methods set to protected or public. So on our superclass, we have here our properties, which are set to protected, and then we have here our method, which is set to public, meaning both of these can be inherited by our car class. Now, talking about our car class, for us to implement our inheritance in Java, we use the keyword extends. So our class extends the name of our superclass. And then right after then, anything protected and public within our superclass can now be used by our subclass. Okay. So if we want to directly access our superclass, we can use the super, like on this example. And so it directly initiates our superclass's constructor once it was called. So I think any other language like Python, even C++, also has this feature where we are allowed to directly access our superclass. Now let's talk about polymorphism. So polymorphism, by the word itself, poly means many, and morph is a form. So it allows objects of different classes to be treated as objects of a common superclass. So it enables methods to behave differently based on the object they are invoked on. So there are two common ideas of polymorphism. So the first one is method overriding, which is our inherited methods are redefined in the subclass, meaning our superclass has a different implementation, then our subclasses could have their own implementation, and that is method overriding. The other one is method overloading, which I think we have mentioned already during the discussion of our constructors. Method overloading allows multiple methods with the same name, but it could have a different number of parameters or of different return types. Now let's dive into our example. Let's start with the method overriding. So as we've mentioned, method overriding is implemented through inheritance. So in method overriding, we start with a method, of course, on our superclass. On this example, we have the make sound. As you can see, its implementation prints some generic sound. When it comes to our subclasses, first, of course, we need to ensure that our superclass is extended by our subclass so we can implement inheritance. And then we have here our method. We have the same access modifier, we have the same return type, then we have the same name. So then we have a different implementation. This is an example of a method overriding. To clearly identify or specify that we are overriding that specific method from our superclass, we need to provide the annotation override. Annotation override specifies that this method is being overridden by the subclass. Okay, as you can see, they have the same structure, but we have a different implementation. A different implementation for the class dog and a different implementation for the cat class. Now let's have another example of polymorphism, which is the method overloading. So in method overloading, multiple methods have the same name. So to implement it fully, we can differ the return types or we can differ the number of parameters. Let's start with this example. As you can see, we have here the method add, but the return types are different. All of these examples have two parameters, but the return types are different. The first one here is an integer, other one is a double, and then the other one is a string. But again, as I've mentioned, all of them have two parameters. So when it comes to method overloading, if you differ the return types, the number of parameters no longer matter. Okay, since they're already different when it comes to the return type. But if you want to maintain the same return type, on this case, we have both integer. So we need to have a different number of parameters. The first one we have two, A and B, and the second one we have three, A, B, and C. This is also an implementation of method overloading. Okay, and then we have, of course, the last one, which is abstraction. So in abstraction, this is the process of simplifying complex systems by focusing on essential characteristics while hiding irrelevant details. So in OOP, abstraction is achieved through abstract classes and interfaces, which define a set of methods without providing implementation details. So that's actually how abstraction works. Specifically on abstract methods, we do not define any implementation. Those methods with implementation, we call them concrete classes, concrete methods. So for us to create an abstract class and an abstract method, we use the keyword abstract. Okay, so on this example, we have the abstract class shape and then the abstract double calculate area as our method. As you can see on our method, there are no implementations and it automatically ended with a semicolon. Now, once this class is inherited by our other subclasses, then we have the implementation by overriding it and making it a concrete method. So as you can see here, as these two classes, circle and rectangle, extends shape or inherit shape. So here we override our calculate area, then converting it from an abstract method, we converted it to be a concrete method. And then since it is overridden, we need to use the annotation override. As you can see here, the implementation on both are different because abstract classes are just our templates or our structure of our class shape. So if you have further questions, you can contact me at aaronpaul.delarosa@bolso.edu.ph or through my Facebook at paul.aaron32493.